Hi all, welcome to Seesaw.com. Here in this video we will learn about the shapes of the AB5 and the AB6 type of molecules. Previously we have discussed the shapes of AB2, AB3 and AB4 type of molecules, and also we discussed what will be the shape of a molecule if you have certain lone pairs also there. So now let's start with the AB5 and AB6, right? So in this video we'll discuss about AB5 and AB6 type of molecules. That means there is a central atom A, and around the central atom A there are 5 B atoms or 6 atoms. So what will be the shape? First let's look at the AB5 type of molecule. So here we have only 5 bond pairs, 0 lone pair. Okay, that means around the central atom A we have 5 B atoms and we don't have a lone pair with the central atom A. So what will be the shape? Simply shape will be trigonal bipyramidal. So that means you have the central atom A here right in the center, and you got 3 B atoms, and now these 3 B atoms are actually in plane, right, forming like a triangle here. Okay, and angle between these atoms will be 120 degree here. You have a one more B atom at the top and one more B atom at the bottom. So this shape, the geometry you get by joining these 5 B atoms will be a trigonal bipyramidal. Why it's called a trigonal bipyramidal is because you can see here the 3 atoms are in one plane, so trigonal shape, and bipyramidal because if you join, suppose these atoms here, so if you join these atoms here and this one, you get a pyramid shape, right? So one pyramid from top, and same thing will happen when you join the atoms here with the bottom one. So you get that's why this is called as a trigonal bipyramidal, right? Here an example will be phosphorus pentachloride, PCl5. The phosphorus here is the central atom, and 3 chlorine atoms will be there in the plane like this. So these are the 3 chlorine atoms. They'll be there in the plane forming just like a triangle here. Okay, and there'll be one more chlorine on top and one more chlorine at the bottom. So the bond angle here will be, so the bond angle you will see in this case it will be 120 degree and 90 degree bond angles, right? So there are two types of bonds. You can see this is the 120 degree and this one is 90 degree. Now what if you actually have a molecule, what do you suppose you replace one of the bond pair by a lone pair from the trigonal bipyramidal shape? So if you have, suppose here, AB4 type of molecule, right, and suppose we got lone pair 1 and the bond pairs are 4, total will be 5. So the parent shape you can expect to be the trigonal bipyramidal. But the problem here is only that I'm going to replace one of the bond pair by a lone pairs, correct? So what will be the shape? Lone pair. Okay, so what will be the shape? The shape will look like this. So it will be like this, right? It will be like this. So B atom is here, B atom is here, over here and over here, and now you have a lone pair of electron at this position. Now, this is not a trigonal bipyramidal shape, right? This is not a trigonal bipyramidal. This will be called as a seesaw, right? And an example with this type of shape is sulfur tetrafluoride, SF4. Sulfur, we know it has 6 electrons in the valence shell. So when it forms 4 covalent bonds with the fluorine atoms, it has a 1 lone pair of electron also. So sulfur will be there with 4 fluorine atoms like this, but there is also a lone pair of electron, right? This is an example of, so any molecule with, you can say, 4 bond pairs and 1 lone pair, the shape will be seesaw, right? So you can say AB4 molecule with lone pair 1, bond pairs of 4, the shape will be a seesaw shape. Now what if you replace 2 bond pairs by the lone pair? Okay, so let me introduce here a lone pair and here also a lone pair. then what will be the shape? The shape will look like this. So it will be like this, right? You got a lone pair here, you got a lone pair over here, and you have the B atoms over here. So how does it look like? Okay, not a trigonal bipyramidal, but this is what we call as a T shape, right? And if you look at this molecule, it is AB3 type molecule, lone pairs 2 and bond pairs are 3, total is 5, correct? And an example will be iodine with 3 fluorine atoms around it. So iodine here, central atom, 3 fluorine atoms will be like this. Fluorine here, fluorines here and here, and you got 2 lone pair of electrons with iodine. The shape is T-shaped, right? And what if you replace all the 3 atoms here by lone pairs? So how does the shape look like? Okay, that means I'm going to take atom A here, I have atom B from top, from here at the bottom, but there are 3 lone pairs like this, right? So the shape again is not a trigonal bipyramidal, rather it's a linear shape, correct? You can see the 2 B atoms and the central atom is one line, so the shape is linear. So that means any molecule with AB2 type, lone pairs 3, bond pairs are 2, shape will be linear, right? Here an example will be xenon difluoride, F2, Xc, F2. Xenon, it has got, 3 lone pairs and 2 bond pairs, 2 fluorine atom in a linear shape. So here you have 3 lone pairs over here, right? So the molecule is linear. Now if you have AB6 type molecule, so that means you have a central atom A, and around this central atom A you got 6 B atoms, and the shape will be called as octahedral, right? We do not have any lone pair. Lone pair is 0, only you got 6 bond pairs right around the central atom A, and the shape is octahedral. 4 B atoms will be in plane, right? And 1 atom above this plane, above the square, 1 atom below the square. But why it is called octahedral, right? Octa refers to 8, hedral means the faces, right? That means this molecule should have 8 faces. That means if you join the B atoms here, and what kind of a geometry you get? You get an octahedron. So if you join here, suppose these 3 B atoms, this is the one plane that you get. If you join this one, you get another one, right? Another face. Similarly, if you join this B atom, this one and this one, from the other side you get another face, right? So you got 3 faces so far. And if you join now this one and this one, again you get a 1 more face here, right? You get a 1 more face. So total you will get 4 faces from top and 4 faces from the bottom from this atom when you join these ones, right? So that means this molecule, you get an octahedral shape once you join all the B atoms there. That's why this is called as the octahedron. And one such example is sulfur hexafluoride, SF6. There are plenty of molecules with octahedral shape, and one simple molecule is sulfur hexafluoride. Sulfur with the center and fluorine atoms there. Sulfur has only 6 electrons in the valence shell. It forms the 4 bond, the 6 covalent bonds. 4 fluorine atoms will be in plane, just like a square, and there will be one more fluorine atom on top of it and one more fluorine at the bottom. So you get an octahedral shape. Hope you got the concept. Thanks for watching the video. Bye for now.